Okay, today we're going to do some more operations with complex numbers. We're given an equation, 2 plus 3i equals x plus yi. Remember that for complex numbers there are real and imaginary components, and the standard form is a plus bi, where a is the real number and bi represents the imaginary number. So this is pretty easy. We're just going to find the corresponding parts, real with real, imaginary with imaginary, and we get x equals 2, y equals 3. That's pretty much it. Okay, let's do another problem. So for problem number 23, it's a little trickier, it looks different, but still going to do the same thing. We're going to combine all of the real parts and the imaginary parts, and in the end we should have a real component and imaginary component that make up a complex number, and then the x and y should correspond to those, where x corresponds to the real component and y corresponds to the imaginary component. So the first thing that we notice is that there are some real numbers, and then the next thing we notice is that there is a negative sign. So we're going to distribute the negative sign through the parentheses, and now we're just going to kind of label all the real numbers or real components in in red, and then we're going to slowly combine those, get them all together on one side. And then when we do that, it works out in such a way that we could separate the real components from the imaginary components, solve for x and solve for y, and we get x equals 1, y equals 2. So just to kind of restate what we did is we separated the real and the imaginary parts, then solve for x, and then solve for y. Anything with an I was an imaginary, and then we took that, set a separate equation, and solve for y. Any real number, we combine like terms, separated, and set equal to x, and in this case we didn't have to solve. It was already 1. For the next problem number 25, we're asked to square a complex number. So I like to use the grid method so I don't forget stuff. So 3 times 3 is 9, 3 times 2i is 6i, 2i times 3 is 6i. Now this next number we have to be careful because 2 times 2 is 4, I squared is negative 1, so we end up with negative 4. Here we combine the real terms with the imaginary terms, and we get 5 plus 12i. Remember that negative 4 is negative because you have the I squared component. So one way to start this problem, we have a complex number raised to the 4th power, which really means squaring a square. So we're going to square the complex number first. Root 2 over 2 times root 2 over 2 actually becomes 2 over 4, which reduces down to 1/2. Well, then the next term would be 1/2 I, and then another 1/2 I, and then negative 1/2, because the I squared represents a negative 1. Here again we combine the real components with the imaginary components. The real components cancel out because 1/2 minus 1/2 is 0. And then 1/2 plus 1/2 just equals I. Okay? Now if you're wondering where the 1/2 comes, the square root times the square root of 2 times square root of 2 is 2. 2 times 2 is 4. Reduce it down. Well, now that was what we squared, but we need to square it a second time. In other words, I represented the innermost parentheses. When we square that, we get I squared, so our actual answer is negative 1, because I squared equals negative 1. So remember, with complex numbers, you're always going to have a real component and an imaginary component. I is equal to the square root of negative 1, and then I squared is equal to negative 1.